What if I told you that a tiny, almond-shaped part of your brain was secretly running the show? I mean, acting as your threat detector, your reward seeker, and your emotional evaluator, all at once. In this explainer, we're going to dive deep into the really powerful and, honestly, surprising story of the amygdala.
So, you've probably heard of the amygdala, right? This little almond-shaped cluster of neurons deep inside your brain. But what does it actually do? Most people think of it as, a simple panic button. But as we're about to see, that's not even close to the whole story. Yeah, the popular story is pretty simple. You see a threat, your amygdala fires up, and wham! You get that jolt, that primal fight or flight response that kept our ancestors from becoming lunch. It's a compelling idea for sure, but it is just scratching the surface. The reality is, the amygdala is way more sophisticated than that. It's not just some simple alarm. Think of it more like a master evaluator. It's constantly sifting through all the sights and sounds and information from the world, trying to figure out what's important, what's valuable, and what really needs our attention. And this is exactly where that simple fear center story starts to fall apart, right? I mean, if the amygdala were just about being scared, its fingerprints wouldn't be all over how we make decisions, or why we struggle with addiction, or even how we navigate a crowded party. So let's get into the fascinating reality of what's going on. The secret to the amygdala's incredible power really lies in how it gets its information. See, it doesn't just use one route to process what's happening. It uses two, and they could not be more different. Okay, so imagine you see something slithering in the grass out of the corner of your eye. Instantly, that visual signal from your eyes splits into two. One part takes this super fast, dirty shortcut, while the other takes a much slower, more scenic, analytical route. Both are headed for the amygdala. So you've got these two pathways, the low road and the high road, and they serve totally different purposes. The low road is pure, lightning-fast, unconscious reflex. It zips directly from your brain's sensory relay station, the thalamus, straight to the amygdala for an immediate reaction. But the high road, well, it's the responsible one. It sends that same signal up to our thinking brain, the cortex, for careful analysis before it gives the amygdala the final verdict.
And the difference in timing here is just staggering. The low road hits the amygdala in about 12 milliseconds. That's why you leap back from that stick that looks like a snake before you even consciously know what you saw. It's only hundreds of milliseconds later that the high road gets the full picture and sends the all-clear message. Hey, relax, it's just a stick. It's a brilliant system.
So it's a beautifully, beautifully tuned system. But what happens when that alarm system is broken? Or, on the other hand, what if it goes into overdrive?
The truly incredible case of patient SM gives us a perfect window into this. She had a rare genetic disease that damaged both sides of her amygdala, giving researchers this unique, unprecedented look at a life lived almost entirely without fear.
I mean, without a functioning amygdala, SM literally couldn't recognize fear in other people's faces or feel fear from things like being held at knife point. But here's the mind-blowing part. She could still feel panic, but only when it was triggered by an internal signal, like the physical sensation of suffocating when she inhaled carbon dioxide. This tells us the amygdala's job is super specific. It's about responding to threats from the outside world.
But for millions and millions of people, the problem isn't a broken alarm. It's an alarm that's basically stuck in the on position. It's an amygdala that's way too sensitive, sounding the alert for threats that aren't even really there. And this state of constant hyperactivity, that's a hallmark of anxiety disorders. And let's be clear, this isn't some rare niche problem. We're talking about the most common psychiatric condition on the entire planet. Globally, about 1 in 7 people will experience an anxiety disorder in their lifetime. And this chart really gets to the heart of the issue. See, in a healthy brain, the amygdala pretty much chills out when it sees neutral, everyday things. But in an anxious brain, that same neutral stimulus, like, say, an unfamiliar face in a crowd, can trigger a full-blown threat response, as if it were a genuine life-or-death danger.
Now, if you want to see what happens when this entire emotional evaluation system just goes completely offline, we can look at the extreme case of Kluver-Bucy syndrome. It was first seen in monkeys with damage to this part of the brain, and it gives us a really startling look at what happens when the amygdala's input is lost entirely.
The symptoms are just profound, and they all stem from one single core problem. The brain's complete inability to attach emotional value to anything. They call it psychic blindness. It means you can't tell what's dangerous, what's food, or what's socially okay. It leads to a total loss of fear, bizarre behaviors, and even a compulsion to explore everything with the mouth, because the brain has completely lost its compass for what things mean.
But you know, avoiding danger is only half the job, right? To survive, you also have to know what to go after. And it turns out the amygdala isn't just about the stick of punishment, it's also very much about the carrot of reward.
This completely reframes the amygdala's job description. It's less of a fear detector and much more of a salience detector. Its job is to tag anything and everything that is important or salient for our survival, whether that's a threat we need to avoid or a reward we absolutely have to pursue.
So the brain's reward system basically breaks down into three big jobs. Liking, which is the actual pleasure you feel, wanting, which is the motivation to go get it, and learning, which is the process of connecting a cue in the world to that awesome reward. And it's in that critical learning step where the amygdala really takes center stage. The amygdala helps weld together that connection between a cue, like, say, the flashing lights of a casino or the smell of your favorite food, and the feeling of reward. Now, this is fantastic for motivating us to do things, but it's the exact same process that gets hijacked in addiction, creating those intense, overwhelming cravings from the simplest of cues.
Okay, so after this whole journey through fear and reward, what's the final verdict? How should we really think about the relationship between our own emotional and rational minds?
You know, for centuries, we've had this idea of a battle raging inside our heads, the passionate, emotional heart versus the cool, logical head. But modern neuroscience is telling us a completely different story. They're not opponents at all, they're actually partners. And this all leads us to a really powerful and maybe humbling conclusion. Our emotions aren't some bug in the system of logic, they are its very foundation. The amygdala's fast, gut-level unconscious appraisals, they aren't just noise. They are the essential data points that guide our rational mind, helping us navigate a world that is just infinitely complex.
Which leaves us with one last fascinating question to chew on. If these deep, emotional, and often totally unconscious processes are the navigators for our conscious thoughts and choices, it really makes you wonder who or what is truly in the driver's seat.